Hey guys, today I'm going to teach you how to do reflections on the coordinate plane. By the end of this lesson, you'll be able to describe and perform reflections of shapes or objects on the coordinate plane. So go ahead and get your binder, turn to the math section, and let's get ready to take some notes. The first thing you need to know about reflections is that a reflection is another word for a flip. A reflection creates a mirror image, just like a mirror would in real life. The thing about reflections in math, though, is that they have to have a line of reflection. So that line of reflection we're going to be looking at today, you can see in these two images. In the first picture, the line of reflection is the x-axis. You can see that the smiley face is being reflected over that. The x-axis acts like a mirror. You'll also notice that each reflected point of that figure should be the same distance from the line of reflection on the opposite side. So just to draw your attention to a couple of those key points, you can see his eye is now on the other side of that line in the exact same spot. It's just flipped around. It's on the opposite side. Same for these other points in the picture. So let's practice identifying the type of transformation that's occurring. What type of transformation do you see here? And do you see that this is reflecting over the x-axis in yellow or the y-axis in red? In this case, the y-axis is the line of reflection. It could be the x-axis or the y-axis in the next couple examples, but we're going to notice some special patterns that occur with each of those situations. So we're going to go ahead and get started with our first example. We're going to reflect the figure shown here, the triangle, over the y-axis. We're going to start by recording the coordinates of the pre-image and plotting our points for the image. Let's start by looking at what we have. I can see that point W is here at the point 2, 6. It goes over 2, up 6. Remember, it's always X before Y, walk before you fly. Now, you should go ahead and plot the points for X and Y in the pre-image. All right, so here are the points that we have, and our job is to reflect the figure over the y-axis. So we need to find our line of reflection. Is the line of reflection shown in yellow or in red? The line of reflection is the y-axis, shown in red. And what we want to do is reflect one point at a time. I'll start with point W. It was at 2, 6. So that means that it was 2 points over on this side of the line. That means it should now be 2 points over on this side of the line. So I'm going to go ahead and take my pen or pencil, and I'm going to just count over 2 from that line of reflection. So this is the image of point W after that reflection. What coordinate is that representing? You should see that it's at -2, 6. So the x value changed, but the y value stayed the same. Go ahead and let's try doing the x value together. We want to start by figuring out how many points over is it from that line of reflection. Since point X in the pre-image is 7 over, I need to count 7 over on this side of the line. So let's go ahead and do that and plot our point. This is the new image point, so we label it X prime, and we need to know the coordinates of this point. The point is at -7, 4. Again, you might notice a pattern here that you're starting to see between the pre-image and the image points after this reflection across the y-axis. Go ahead and try reflecting point Y all by yourself, and then press play whenever you're ready to check. All right, so we've reflected each point of the pre-image. Now we have an image. All we have to do is connect the points. It should look like it's looking in the mirror, and that this line of reflection is the mirror it's looking in. So at this point, you should notice that there was a pattern between the pre-image points and the image points. Go ahead and tell me what you think the pattern is that you have found in these ordered pairs. You should have noticed that all of the x values became the opposite of the x value in the pre-image, but the y values stayed the same. So algebraically, when we want to put this as a point, we still want to put x comma y. However, since the x values are the opposite, we want to put a negative sign in front of that x. Remember, the negative doesn't mean that it makes the x negative. It just means what's the opposite of the x. So if you put in a 2, the opposite of a 2 is a -2. And that's what that little negative sign is going to mean in this algebraic representation. So you might want to make a note that in a reflection across the y-axis, the x-coordinate will be the opposite. The y-coordinate will stay the same. Let's see if we can discover another pattern in the next example. In number 2, it says reflect the figure shown over the x-axis. Then we're going to record the coordinates of the pre-image and the image that comes after the reflection. So let's start just like we did last time. Go ahead and plot the points of the pre-image and write those coordinates into the table. Go ahead and do that now and press play when you're ready to check. All right, now that we have the points plotted for the pre-image, we need to go ahead and identify our line of reflection. The question says we need to reflect over the x-axis, so is that the red line or the yellow line? The x-axis is the yellow line. And remember, a reflection is a flip. So we're going to take each one of these points and flip it to the other side of this line. So we need to make sure that each of these points is the opposite distance on the other side of the line. So I'll start with point D. If point D is 2 down here, it needs to be 2 up from this point on the line. What are the coordinates of the new point D? D is now at 2, positive 2. And you're going to want to do that for each one of these other points. You're going to want to put them on the exact opposite side of that line of reflection. So go ahead and try that for point E and point F, and then press play when you're ready to check. All right, so we've reflected each of these points from the pre-image to the image, and we've put them in the table. The next step is to go ahead and just connect those points. After looking at the points in the pre-image and the image, you should have found another pattern. Did you notice what happened? This time the X values stayed the same, but the Y values became their opposite after reflecting over the X axis. Looking at the example we did here, how can we represent this situation algebraically? Since the X stayed the same, we left it just as X, but the Y is the opposite, so we put a negative sign in front of it. Since that's what opposite means, it's that little negative sign, that means the opposite. All right, so now it's time for you to try some. We're looking at number 3, and that's what I want you to do by yourself. You're going to start by reflecting that triangle PQR over the Y-axis. Then you're going to describe what happens to each of the coordinates. Go ahead and try that now and press play when you're ready to check. All right, so this is what your new triangle looks like. Now we're going to do a series of transformations. That wasn't the only reflection we needed to do. Now we need to reflect our new triangle, the one we just drew, over the X-axis. So go ahead and try that now, and then describe what happened to each of those coordinates. Press play when you're ready to check. All right, so here's our reflected image again. So since it was reflected twice, there's 2 little prime symbols. And we also just want to point out that this is the same thing that you noticed in our last 2 examples. The algebraic representation is still going to be true. When you reflect across the Y-axis, the X value will be opposite. And if you reflect across the X-axis, the Y value will be opposite. So this is just a handy little pattern for you to notice, especially if you're not given a coordinate plane. If you weren't given a coordinate plane, you could always make one yourself, graph it yourself, and make those connections, but you don't have to. You could just look at the pattern that occurred. All right, let's look at number 5 and number 6. In 5 and 6, we're both looking at translations and reflections. Those are 2 types of transformations, and we want to focus again on translations being slides, reflections being flips. So looking at this image, and especially paying attention to these points on here, is this a translation? Bella thinks it is. Is she correct? Why or why not? What do you think? Bella is incorrect. And if you notice, look at each one of these points. H is on the other side of the line here. And if it was just a slide, the H would be in the same place. The orientation would be the same. But since it was flipped on the opposite side of the line, same for the G here, this would be our line of reflection. This is a reflection, not a translation. So keeping that in mind, let's compare and contrast some more about translations and reflections. How are translations similar? How are they different? You could have said several things for this, but to me, the biggest similarity is that the pre-image and the image are congruent. It means they're the same shape, same size. However, a translation is a slide. A reflection is a flip. That's the biggest difference. And if you want to talk about orientation, the way that the figure is facing, in a slide, the orientation will be the same, but in a reflection, it'll be totally different. It'll be flipped. All right, just to close out today, I'll give you a choice. You can do either 7, 8, or summarize today's lesson. If you're feeling ambitious, you could try all 3. All right, guys, that's it. If you made it to the end of this video, I want to know if you could have a clone of yourself for just one day, what fun activities would you do together? Today, we learned about reflections on the coordinate plane. So now you should be able to describe and perform those reflections on shapes and objects in the coordinate plane. Now you should go ahead and go back to the calendar and complete any other assignments you have left for the day. Let me know if you have any questions. Bye!